Okay, so now we are going to move to another section of our conference, and we would like to invite our user from Croatia, from Geocenter company. They are professional surveyors, as I already said, and they provide special survey equipment as well. And we invite Victor to make his presentation.
Hello, my name is Victor. I come from Geocenter, Croatia, and I'll be talking a little bit about mapping of unaccessible river terrain with TOPODRONE DJI Mavic 2 Pro with PPK RTK GNSS receiver. So for start, a little bit about Geocenter. Who are we and what do we do? Well, we were founded in 1991, so we are a 29-year-old company with a team of 6 people. 4 of us have master's degree in geodesy, so we are quite familiar with geospatial data. And we also have a colleague who has a degree in informatics, so we are really very well equipped with knowledge. Geocenter is a distributor for the survey equipment for area of Croatia and Slovenia, and of equipment, and to test the equipment ourselves. We are a distributor for the TOPODRONE equipment, and also when we make demonstrations we use TOPODRONE equipment, so we are going to show you a project that we did as a demo. Geocenter has more than 20 years of GNSS experience, and we as a company were the ones who first introduced the RTK technology in Croatia. And also we have more than 5 years of photogrammetric experience with UAVs and also terrestrial photogrammetry. And we tested, and also we use and sell different UAV solutions, fixed wing and multi-rotor. So I would conclude that definitely we have a lot of knowledge and experience. Now let's talk about the project. So the project we did was a demo for one of our potential customers who needed to make a map of an area of the river for a civil engineer who was making a preliminary design, and he needed to see how does the area look like so he can make the design. So he requested an orthophoto, a rough estimate of terrain surface, volumes of the volumes of the water if the water level rises, and also profiles along the river. So the project sounded really interesting, but it came with some challenges. What were the challenges? Challenges were that the terrain was quite difficult. What does it mean? Well, it was really hard to reach. It was hilly. It was covered with weeds and thorns. It was forest covered it. You can see these 2 pictures are actually pictures The pictures are actually from the terrain itself, and you can see that it is really a rough terrain. On the upper picture, you can see that on one side of the river, the terrain is okay. There are fields you can get close to the river. But on the other side, there is forest, there is hill, and that presented a problem to use the regular photogrammetry, because you cannot place the GCPs in a way that should be placed. You cannot place them nice and evenly spread. So then we saw that the PPK solution was really perfect, because there is no obstacle of using PPK in the air. Also, one of the challenges was that we only had 6 hours of usable light to map 3.6 kilometers of the river using only 3 batteries, which had a bit shorter time because it was winter time, so it was colder, and we could only get maybe 15-18 minutes from one flight. but later we managed to do that because we planned our drone flight plan quite well. We used for flight plan we used corridor mapping mission, which allowed us just to draw a line along the river, and it created the 4 lines we wanted. With front overlap of 80% and side overlap of 70%. And to maximize our batteries, we flew at 100 meters. The resolution at 100 meters isn't the best with the Mavic camera. It's maybe 5 to 7 centimeters. But the civil engineer only needs the rough estimate of the surface and the orthophoto just to roughly see how does the terrain look like. So their resolution we concluded would be just fine for him. After the flight, we processed the data using the TOPODRONE software, which was quite easy because you just select the folders with photos, you select the UBX GNSS log file, and we used the Rhinex from the base station of our local course network. And as you can see on the right picture, the whole trajectory of the drone fixed, and we had really no issues with getting good positioning data with the TOPODRONE. After TOPODRONE processing, we used that data to process the images in the processing software. Our processing software of choice is Agisoft Metashape because it has rolling shutter compensation. It can also simultaneously calculate the positions using photo positions from PPK and also using GCP positions. And the most important thing probably with Agisoft Metashape, you can really get good quality results. After processing there, we wanted to check the quality. And as you can see here, we used a minimum of 2 GCPs per flight because 2 GCPs are enough to fix the camera calibration parameters. And those GCPs were marked with the spray marker. We just drew the cross and determined the coordinates of that cross using survey grade GNSS antenna with RTK positioning using our course network, which is within 2 to 5 centimeter accuracy. And the total error at the end of the project we got was 1.8 centimeters, with maximum error on one point was just below 4 centimeters, which is great if you take in consideration that the GCP accuracy is within 5 centimeters. Then after the aerotriangulation processing, we got really good accuracy results. And then we went and made the products like dense point cloud and high resolution orthophoto. Orthophoto was directly given to the civil engineer, and dense point cloud was then used later for processing to get the ground. We are aware that photogrammetry isn't the best method to get the ground when there is vegetation, definitely when there is forest, but for this project the accuracy was good enough, so we went with it. So we used that dense point cloud to make ground extraction, and ground extraction gave us ground seed points. Those are these blue and red points. Below them you can see the orthophoto, and these points represent the points on the ground. And later on we use those points to generate the digital surface model, or DSM, which was used for several things. First thing we used it was to create contour lines, which were required to make a map using in combination with orthophoto. Second thing we used it was to calculate volumes. because the civil engineer wanted to know what volume of the water is going to spill out and if the water level rises. And then the final product the civil engineer wanted were the profiles, so you can of the river along the river path. So on the upper picture, I hope you can see it's the cross section of the cloud, which was then used to make profiles like these two below in Kent. So to conclude, the photogrammetry provides adequate accuracy for preliminary design. Although we used it for mapping the forest, it was just okay for the accuracy that was requested. The PPK solution was really ideal for mapping of this hard-to-reach terrain because there is no way to place the GCPs as they should be placed with good positioning, and it is really hard to go through all that vegetation to place those GCPs. So PPK was really the right solution for this project. And we can definitely conclude that TOPODRONE provided really reliable and accurate data. We got fixed solution everywhere, and as you saw, the positioning accuracy was quite good. And at the end, using the appropriate software, you can get really good deliverables that can meet the requirements from the civil engineer. So yeah, I think that's it from my side. If you have any questions, I would be happy to answer.
Thank you for your presentation. I think right now there is no any questions, but I would like to ask, what would you prefer? I know that you use a lot of type of drones and a lot of GNSS base station. What would you prefer? To install your own base station in the field, or to use N-Trip or coarse network to download data?
Well, when we do our projects, we mostly prefer to use coarse data that we download afterwards, because it's much faster at the field. You don't have to place your GNSS antenna, and also you are not dependent on the internet connection in the field. We are lucky here in Croatia that our coarse network really provides good coverage, so we can use the coarse network, I think, everywhere in Croatia. We didn't encounter any problems with that. We also tried using our own base station, which worked quite well, but as I said, it's much convenient for us to just to download the coarse station data.
Okay, and what about type of drone would you prefer? Do you like to use Mavic or Phantom 4 Pro? What is the best solution in your opinion?
I think that it's a difficult question because every drone has its pros and cons. Mavic is of course quite compact and small. You can carry it almost anywhere. But on the other hand, the Phantom 4 has the global shutter, which is much better for the accuracy. So I would say it depends. If maybe you're going somewhere like this terrain where you know that you're going to be, it's going to be difficult to carry a lot of big stuff, then I would use Mavic, and otherwise I would definitely use Phantom 4.
I think it's a very good answer, and my opinion, it totally is the same. But as far as I know, you provide training for your customers, and how do you think what type of knowledges surveyors should have to use drone for surveying? What type of knowledge? What type of skills? Is it difficult to start to survey with a drone right now?
Well, I would say that it is quite easy. Since we are the distributors, and as you said, we also make educations for our customers. I have experienced different customers with different base knowledge. So some of them need maybe a few hours, some of them maybe need 1 day and a few projects just to get the hang of it. But as far as acquiring the data, it's quite easy today with all the automated planning missions, where you just select the area which you want to map and then you just play start and it does the job. And I would say it's really accessible today, that almost anyone can learn to make mapping with drones. Maybe the most challenging part is to overcome your fear of drones, and also to understand some basic principles of GNSS and how it works. So.
And how do you think GNSS data post-processing, is it a simple process, or you need to know some knowledges or something like that? Because usually people know how to fly, or other hand, they know how to process GNSS data. But concerning GNSS data post-processing, is it simple right now, or or customer should have additional knowledges?
Well, it's definitely good if customers understand what is happening with GNSS post-processing, but I think there is no need for some advanced knowledge, because, for example, TOPOSetter software is quite easy to use. You just have to pick the GNSS log from the drone, you pick the base station, which you can really easily download from your course network, and you just hit play and it mostly does the job. In some specific situation, maybe you won't get immediately all the fixed solutions, so you maybe have to do some adjustments, or maybe some people don't understand the concept of time overlap between the base station and the drone log, but those are minor problems that a lot of people catch up really quickly. So I don't think it's something to be afraid of.
Okay, Victor, thank you very much. And I hope that we will contact later and we will discuss the new business possibilities. And we are going to move to another presentation. Thank you very much.
Okay, thank you.
Bye. Bye-bye.